All right, welcome, ladies and gentlemen, to the last section from Chapter 4. This is dealing with problem solving, using trigonometry to do that problem solving. And you got to remember that in math, the word problem solving really means word problems, and that just means using the trig in the real world. So let's go ahead and look at a couple of things. First, we have to define a couple of terms. The first of those, actually the two that we're going to define here, are things called angle of elevation and angle of depression. These are very important for us because word problems like to use these two terms, and we need to know what they represent. So angle of elevation is measured from horizontal upwards, and that it almost kind of makes sense. You have to elevate your eyes to see the top of a building or a tree or something like that. If you elevate your eyes to see the top of the tree, you are measuring the angle of elevation. Or in the other fashion, if you are on top of something and you are looking down at, let's say, a car. That's a really good-looking car. And you're looking down. The angle that you measured in this direction is the angle of depression. So you are looking downwards towards something from horizontal. That's measured as the angle of depression. All right. I'm not going to be using, well, no, I guess I am using in the next example here. And I'm basically just going to be doing a couple examples in this particular video. First one that we do is we do what's called indirect measurement. And that means finding the distance or the length of something without actually measuring it, but knowing certain pieces. If you knew the length of your shadow and the angle of elevation of the sun, you could actually determine how tall you are. Kind of a weird way to do that, but you could actually determine the height of a tree given an angle of elevation and the length of the shadow. So what we're going to do is we're going to say, okay, we're at the top of a 100-foot building. You see some car, and it's moving towards the building. The first measurement that you found was the angle of depression to the car at one point in time was 22 degrees. Then later, the angle of depression was 46 degrees. So it's changed from 22 to 46. And you want to know how far has that car traveled? Well, as with most word problems, we want to try to figure out a picture of what this represents. So there's your building, and out here is the car at some point in time. And so you've measured the angle. I'm going to put a dash line because this line doesn't really matter here. But you've measured that angle of depression to be 22 degrees. You then, or not you, but the car then moves out to here somewhere. And you now create a new angle of depression from horizontal to get 46 degrees. The question is, how far did the car travel? Well, the car traveled from this point A to this point. I guess we could have called it B, but I'm going to call it the car. So we're looking for that distance there. We know the height of this triangle. Notice I drew a triangle. That's very key for us. The height of this building was 100, and we know the building stands at a 90-degree angle. Now that's very key for us in this chapter, chapter 4, because all of our triangles are right triangles. So I need to call this something. I just can't call it x. I'm going to call it y because it's not the same distance as x. And you'll notice that these two angles are actually outside of my triangle. So what I'm going to do is I'm going to use a little bit of geometry to help myself out. Because this horizontal line, this dashed line, is parallel to the ground, this angle 22 is also this angle 22. And I also know the same thing for this. If this is 46, this is 46. Now, you didn't have to know that. You could have done that this is 46 and therefore this angle is 90, and thus this angle would be the 44. I'm going to use the 46, however. So if I look at this first triangle, there's a lot of things that I could figure out. I could actually figure out the length of y using what I know about trigonometry. I know, according to this 46-degree angle, I have 100 and y, so that's the opposite and the adjacent. So I can say that the tangent of 46 degrees is equal to 100 over y. And if I wanted to solve for y right here, I would multiply both sides by y and divide by the tangent of 46. So I get y is equal to 100 divided by the tangent of 46 degrees. Well, y is not actually the thing that I want to find, but I need to do that to help me find x, because I have a large triangle, and this side has to deal with x and y. So if I look at the big triangle now, I have an angle of 22, and again, I have the opposite and the adjacent. So I can say that the tangent of 22 degrees is equal to 100, so the opposite side, divided by the length of this adjacent side, and that's x plus y. Now, I'm not going to plug in the y yet because that makes my problem a lot harder. But what I'm going to do is I'm going to solve for this denominator. So I'm going to multiply both sides by x plus y, and I'm going to divide by tangent of 22. So therefore, x plus y is equal to 100 over the tangent of 22. Since I'm looking for the value of x, I'm going to subtract y from both sides. That means x is going to equal 100 over the tangent of 22 minus y. But I know y is this value over here. So y is going to equal 100 over the tangent of 46 degrees. And I can now plug this into my calculator. And if I plug this into my calculator, I should get 150.9 whatever. I guess we're dealing with feet, so my answer is going to be in feet. Make sure if you're doing this at home that your calculator is in degree mode because it doesn't work in radians. These are real-world problems, so most of our stuff comes in degrees more than the radians. All right, so that's that problem. We just determined how far the car traveled by just knowing some angles of depression and the height of the building that you were standing on. So something else that we are going to have to do is something to do with bearing. You're going to have to be able to draw pictures using bearing. If I told you that a boat traveled at a bearing of 53 degrees, you have to understand that it's not the normal 53 that we're used to. A bearing of 53 degrees comes from north. Never eat shredded wheat. Okay, 53 degrees is here. That's a 53-degree bearing, or sometimes they call it on a course or bearing course. But when we're dealing with boats and planes, we have to deal with bearing. So if I said you traveled at a 53-degree bearing, so we just put a dashed line for north-south, and we traveled at a 53-degree bearing. Let's say we traveled for 2 hours at 35 knots, which means nautical miles per hour. So this would be 70 knots. And then at some point in time after 2 hours, we changed directions. So from there, we traveled 143 bearing. So 143 from north, there's 90, and another 50 will get you to 143 degrees. And here you traveled for another 3 hours at the same pace. So 3 hours now is 35 times 3, so that's 100 and, shoot, what's my number here? 105. Couldn't do my math there. It's 35 times 3. And then the question would be, how far away and at what bearing are you from your original destination? Well, because this is a 143-degree angle and this is a 53, we can actually do some simple math to determine that this is a right angle. Which, if this is 70 knots and this is 105, that's two sides of a right triangle, which means I can solve for the third side. C is the square root of 70 squared plus 105 squared. And that equals 126.2. And this would be knots, or nautical miles. And then we need to know the original bearing from where you're at. So it would be a good idea to find this angle because this is where you started. And from that, I can just actually do the tangent. I can do tangent. If I called that angle theta, I can do tangent of theta is equal to the opposite over the adjacent. But in order to solve for theta, guess what? We have to use our friend, our new friend, tangent inverse of 105 over 70, which gets me 56.3. Well, that's actually not your answer. That's just this angle here. So it's the original bearing of 53 and another 56. So the bearing is 56.3 plus 53. So it's 109.3 degrees. So the bearing is 109.3 degrees, and you're 126.2 knots or nautical miles away from where you started. All right, so what I'm going to point out here is the things you should do. You'll notice exactly what I did in both of those problems. I drew a picture, and it had to have a right triangle in it. We can't solve anything yet without a right triangle. We will come the next chapter, but right now we cannot. I created the trig ratios that were involved in the problem. A lot of the times it's tangent, but that's not always the case. And then I went to solving the part that was required. So you have to read the question very carefully, make sure you know what it's trying to ask you, and make sure you answer the question that's being asked. Don't just stop because you think you have the answer. Okay, that actually finishes this video off. It finishes off our chapter 4. I've hoped you've learned a lot throughout this chapter, and I think we are all ready for what comes next. All right, I will see you guys tomorrow.